Good afternoon, everyone. Welcome to the Year in Flash in Mandalay, BCD. Couple quick announcements. The Business Hall is in Bayside AB. Black Hat Arsenal is on the Palm Foyer on level 3. The Kali Linux Lab is in Mandalay Bay A. And thanks for putting your phones on vibrate during the talk. So let's welcome Natalie Silvanovich to talk about the Year in Flash.
Hi everyone. Today I'm going to talk about finding and exploiting bugs in Adobe Flash. I've been doing a bit of a security review of Flash for over a year now. So today I wanted to share with everyone how that year went. What sort of bugs I found, what sort of exploits turned up in the wild, and what sort of mitigations were implemented to prevent them. But before I begin, who am I? I'm Natalie Silvanovich, and I'm a security researcher on Google's Project Zero. Before that, I worked in mobile security on the Android security team and at BlackBerry. And something that a lot of people don't realize is up to about 5 years ago, back in the dark ages, it was really common for virtual machines to be the root of trust on a mobile device. The most popular one was the Java virtual machine, but a lot of other virtual machines were used. There was even a BlackBerry device, the BlackBerry Playbook tablet, where Adobe Flash was the main VM. So that's how I got really interested in Flash. Now I would say I am a Flash enthusiast. I love finding bugs in Flash. I love making the sad puzzle piece appear. And currently I report about 1/3 of Flash vulnerabilities. So what's my goal? I want to find all of the Flash vulnerabilities. I want to find every last one, and sometime around 2022, I will have found the last Flash vulnerability, and that'll be it. Flash will be secure. Now, obviously, this isn't a very realistic goal. What I really want to do is make Flash better. And my biggest priority in doing that is finding bugs in Flash. What I want to do is find so many bugs in Flash that it decreases the density of bugs so that it becomes harder for other people to find them. I spend most of my day doing code reviews looking for bugs, but I also do some fuzzing with my colleague Matthias Hurek. When I started off looking at Flash, I was finding 1 bug per day, and now I'm down to about 1 bug per week. And one last thing I want to mention is that development on Flash has mostly stopped. So this means that if you find a bug in Flash and get it fixed, it stays gone. And this means that Flash represents a unique opportunity to make an impact by finding and getting bugs fixed, because this will definitely reduce the total number of bugs in Flash. I also spend some of my time analyzing external bugs and exploits in Flash. I'm not just interested in my own bugs. I want to know about all the bugs in Flash that turn up in the wild so that I can understand them better, find similar bugs, and also understand how they're exploited so we can work on things like mitigations. Also, I occasionally exploit Flash bugs, mostly to answer questions. Sometimes I want to find out whether exploitation is possible, whether it's reliable, and how certain factors impact exploitability. One of the reasons I do this is so that people on my team can work on Flash mitigations, certain technologies that will prevent exploitation. So what am I going to talk about today? There'll be 3 main things. First, I'm going to go through the attack surface of Flash, just in case anyone isn't familiar with it. And then I'll go through this year in Flash, what the new bugs and bug classes are that turned up. I'll talk about 0 days, 1 days, and other exploits, the mitigations that were implemented, and finally I'll talk a bit about the future of Flash, what I think the landscape of exploitation and bugs will look like in the future. So to start off, what is Flash? There's 3 main components. The first one is AS2, the ActionScript 2 VM. This is the original Flash VM, the very first thing in Flash that executed bytecode and script. It's basically a big while loop with not a clear boundary between the VM and APIs, and it has a reduced API set because it was eventually replaced with ActionScript 3, so it only has the original features that were in Flash. And I would say it generally has more bugs with lower exploitability than ActionScript 3. The thing about ActionScript 2 is it was written before the modern security environment. So a lot of choices were made in the design that would probably be not made today. For example, it doesn't do automatic type checking on variables. Instead, the developer writing a native API has to manually check every type. And certain features like this that are hard to fix at scale cause it to generally have more bugs. But the flip side is that bugs in ActionScript 2 tend to be a bit less exploitable. And that's because ActionScript 2 just has less stuff in it. Because it doesn't have as many features, when you're trying to exploit a bug, for example, fitting something into the slot of a use after free, or fitting something into memory so you can overflow it, you have a lot less options because there's not so many objects in ActionScript 2. And sometimes people writing exploits get around this by loading AS2 into an AS3 frame. And this will sometimes work, but it doesn't always work, because sometimes you have a bug which has a very narrow window. For example, let's say you have a pointer that gets freed and then used, and then it goes out of scope. That window is sometimes too narrow to be able to execute ActionScript 3, so then you're back to ActionScript 2 exploitation, and that doesn't always work. AS3 is the answer to ActionScript 2. It is the current modern ActionScript VM. It's open source, which is kind of cool. If you look up Tamarin on Mozilla, you can get the source of the main Flash VM. And it has some good features. It has just-in-time compilation and a fallback interpreter. It is extendable. So if you want to write your own Flash APIs and compile them yourself, you totally can. It has a garbage collected heap. It's a fairly conservative heap. I'd call it non-strict, non-exact. So things don't get freed right away, but they do get eventually freed. It also has a fixed heap, and this is for long-lived objects, for example, bitmaps, and these need to be manually allocated and freed by the developer. And ActionScript 3, the VM, is optimized for Flash, but as I said, it's open source. You can use it for whatever you want. With regards to the actual ActionScript APIs, some of them are open source. The really important ones like string and vector and array, you can see the source of them online. And then there's some Adobe proprietary ones, for example, bitmap filtering, that are not open source and you can't see the code of. I would say bugs in ActionScript 3 are a bit less dense because it does have some good features that prevent bugs, for example, automatic type checking. But the flip side is that bugs in ActionScript 3 tend to be highly exploitable because there's lots of features in ActionScript 3 you can use for exploitation. The final component of Flash is the anti-corpus. And this is basically all of the functionality outside of script. This is the MP4 parser, zlib, regex, image decoders, all that sort of thing that isn't exactly script, but is part of Flash. I'm also going to start with a quick warning. Objects in Mir are larger than they appear. If you've ever worked with Flash, one problem with it is that objects are really, really large. So in some situations, I've had to compress them for the purposes of these slides. So everything's conceptually correct with regards to how the bugs work, but if you try to use these slides for, say, exploitation, they might not be 100% correct. So all the bugs are on the Project Zero tracker. You can look them up by CVE and get all the nitty-gritty details, but just be aware, I've omitted a few small things in some of these slides. So starting off with the year, I'm starting off with last July, and that was actually a super interesting time in Flash, mostly because of the Hacking Team dump. Just in case anyone doesn't recall, Hacking Team was an organization that sold Flash and other vulnerabilities to a variety of customers. And they themselves got hacked, and all their emails and exploits and source code got dumped online, and everyone could see them. And this was actually really interesting. Because at the time, while we did have some samples of Flash 0 days, we didn't have tons and tons of information about how attackers actually attacked Flash. And this was a great source of information because there was actually 5 vulnerabilities and the source of all the exploits. So in total, this dump contained 5 bugs, and 3 of them were very similar. There were the 2 0 days, which were both use after freeze. I call them byte array and opaque background, which is the features they were in. And then there was also a convolution filter issue. And all these 3 bugs are basically very similar bugs in different components. And that one was used by Hacking Team, but it eventually closed up. There was a 4th issue, which was an overflow in function .apply. It was a very simple buffer overflow. And what was interesting about that is in Hacking Team's emails, you could see that they actually had this bug ready for use, and then it closed. And the reason the bug was fixed was that it was recorded to the Chromium VRP program. So I think that's kind of cool. That's an example of a bug bounty actually preventing a bug from being used by an attacker. And then finally, there was a fifth bug that got fixed, which turned out not to be exploitable, though it was easier just to fix it at the time. So I'm going to give this as an example of the 3 bugs that showed up in the hacking team dump. This issue is the convolution filter issue, and it's interesting because it was actually discovered independently 3 times. I reported it to Adobe, and then it was used to win Pwn to Own, and then it turned up in the hacking team dump. So at least 3 people discovered this bug. And this bug happens due to a feature of Flash called redefinition. And this is what most people would call monkey patching. Basically, you can define any function to be any other function in ActionScript 2. And what makes this even worse is that in ActionScript 2, native methods generally accept any type and then convert it. So let's say you have an API that accepts a string. If you put in an object with a 2-string method, most Flash APIs will actually try to convert it. And that can be problematic security-wise. So in this particular bug, what happened is you create this object called a convolution filter. And there's the object. And then you create this other object, which is an object with a function called value of, and then it's in an array. And then you call the filter matrix setter. And what this attempts to do is copy this array into memory so that the filter can use it later. So it does this. It starts off by allocating the memory to keep the array in. And then it attempts to convert the array to all floats, because that's what it needs to store. So it does this, and in this case, it calls this method, and then what you can do, which causes the vulnerability, is call the setter again. So it starts over. It has to delete this memory because it needs to allocate new memory, and then it allocates new memory and sticks the pointer to it. And in this case, it works properly. You have the element of 1 that gets copied into the float array. But then the original setter needs to unwind. So that will write to the freed memory. And this is a use after free that caused this vulnerability. And the other 2 hacking team issues were exactly the same thing, more or less. One of them was when you were setting the value of a byte array. If that was an object, then you could delete the byte array and then use it after it's freed. An opaque background was if you set the background of an image, you could delete the image as the background was converted and then write to unallocated memory. As a result of this, this type of bug, especially value of and 2-string bugs, received increased attention. Many, many similar bugs were reported in the next few months, and Adobe started efforts to preemptively fix similar bugs. In July, there were also 33 bugs in the regular update, and the first mitigation set, vector mitigations, were implemented. The vector mitigations protected against a very, very common type of exploit in Flash. Basically, in Flash, there is this class called the vector, and it has data, and this data has an inline length. And this class turned out to be really, really good for exploitation for a couple of reasons. One of them is that it could be any size. You could have a small vector or a big vector. And also it can be any type. You can have integer vectors or object vectors. So for most bugs, it's really, really easy to make a vector of the correct size and then use the memory corruption to corrupt the length. And then this means that the next time you access the vector, you can read or write anywhere in memory, and then that's really useful in exploitation. And at this point, a really high number of vulnerabilities, including the hacking team vulnerabilities, were exploited in this way. This is what most attackers used. So what the vector mitigation did was twofold. First, it added checksums to vectors, so if one did get corrupted, the checksum would be incorrect. And then the next time you access the vector, Flash just crashes gracefully. It also puts some vectors on their own page so that it's really hard to get a bug that will allow you to corrupt them in the first place. And this had a few effects. One of them is that it really reduced the reusability of exploit code. If you looked at the hacking team dump, some of the bugs they used were like really, really crummy bugs. Things like, for example, the byte array one, you could change 1 byte in an array to be a value you wanted as a part of the use after free. And, in a lot of situations, that wouldn't be a great bug, definitely not a highly exploitable bug, but because of this methodology, even not very good bugs were highly exploitable. So this made it so that you couldn't use really low-quality bugs for exploitation, or at least not as easily. And it also reduced the reusability of certain exploit code. Attackers had to at least write some new code for every bug. And some people say that you can substitute the byte array or bitmap data for a vector. And this is true, but it's not as good. The really good thing about the vector was that you could change the size and type of it, and you can't do this with a bitmap data or a byte array. You need to have a better bug, either one that lets you change the size of the thing that you can corrupt, or one that happens to have something you can corrupt that is exactly the size of a byte array or a bitmap data. So this tends to be a lot harder than just using a vector. So another interesting bug that got fixed in July was this redefinition issue using value of. And this is another example of how being able to call script within natives can cause problems. So in this bug, you start off by creating an array. And yeah, you put stuff in the array. And what's really interesting here is that in ActionScript 2, you can actually set the length of an array to be anything, including an object with value of defined. So that's what this object does. And then you can call this vulnerable function called sort on. And what this does is it actually fetches the length a few times. So to start off, it checks the length, and in this case, because it's an object, it tries to convert it, and then it returns 100,000, and that's not 0, so that's fine. So then it calls it again, and in this case, it stores the length, and it will call into the method, and it returns 100,000, and that's fine. And then one more time, it fetches the length to allocate memory. And this time it returns 2. And I think everyone can figure out what happens next here. It does an memcopy on this array, and the length is way too big, and that's an overflow. And it's actually a fairly useful overflow because you can both change the size of the thing that gets overflowed and the size of how much you overflow. So moving on to August, a lot of bugs that were similar to the hacking team bugs got reported because they got increased attention. And also, reports of a class which I call MCUs after freeze started to pour in. This is a very, very common bug. I think 100 or more of them have been reported this year, and by this year I mean 2015. It's a really, really common bug class. The downside of it is it's a very small variety of freed objects. So all of these use after freeze. There's basically only 2 object types that get freed, but there's many, many instances of this bug. And the root cause is that display fields are freed outside of garbage collection. Even if there's references, they are always for real freed when they're deleted. And I think part of this has to do with how display fields look and preventing lag. Because you can imagine if you're trying to make text scroll across a screen, you might do create text field, delete text field, create text field, delete text field, create text field, delete text field. And if it's not really being deleted, then you might get something like create, garbage collect, create. And then that can have all sorts of unusual effects, including lag on the screen. So instead, a flash will really delete the display field, and that can lead to vulnerabilities. More specifically, this happens when function parameters are converted after local variables are initialized, but before they are used. And the way this type of bug is generally fixed is by enforcing a convert initialize use order. And actually, if you look at browsers that can be susceptible to similar problems, this tends to be how they fix it. They have a strict coding guideline that requires conversion before anything else. And it is sometimes hard to tell exactly what order things happen in really complex code, but this tends to be the best way to generally prevent this type of issue, is to enforce an early conversion order. So here's an example of this issue. To start off, you create a movie clip, and only one of these is relevant, so I'm going to show that one. And then you create this object that is supposed to be a string, but is actually an object that does string conversion. And then you call the vulnerable function, which is in this case swap depths, but many, many functions are vulnerable to this type of problem. So what this will do is in swap depths, it will start off by initializing pointers to both the script object and the movie clip object, and then it will try to convert this parameter to a string. And this calls remove movie clip, which deletes the movie clip. And then these are dangling pointers. And then the function will continue, even though the movie clip has been deleted, and it will use these pointers that now just dangle on the heap. So moving on to September and October. 23 bugs were fixed in September, and 20 were fixed in October. And they were a lot of those MCUs after freeze, and also other redefinition bugs similar to the hacking team bugs. And And there was also a 0 day reported immediately after the October update. What was kind of interesting about this bug is that it actually turned up in the wild 2 weeks after I reported it. And it was part of the open source AVM, so I can actually show you the code of it. And it was this bug, and then there were 2 other variants that I also found that were fixed in the emergency patch. And I just want to mention that this bug in particular doesn't compile. I'll be showing you ActionScript code, but if you try to compile this at home, it won't work. So the way I actually did this was by writing the bytecode directly in the Swift. So here is the first bit of the code that causes this vulnerability. This is in the ActionScript 3 AVM. And what it does is it finds this binding, and then if it's not binding none, it throws a verify error. And what this does is it prevents you from overriding a function in a class with something that is not a function. And you'll notice that this check has a very serious problem. It is commented out. So this shouldn't be allowed, but it is. So just to reiterate, this is what should violate your sense of all things object-oriented programming that is allowed. You have this function write external that is a function, and then in the subclass, you can define it as an integer. So here's what happens in the ActionScript virtual machine when you can do this. This write external function is actually kind of special. It's what you use to override serialization in Flash. So let's say you're trying to serialize an object and you don't like what Flash does. You can define write external, and then you can take in the object and put out your own bytecode, and then you have to define a complementary function, read external, and that will take in the byte array, and you have to give them an object back. So this code is where it attempts to actually implement this and fetch the write external and call it when you're serializing an object. So the first thing it does is it gets this binding. But note that you were allowed to overwrite this with an integer, so it is not a function binding. So this m function binding is not correct. And then it will use this function binding to index into a method table, except that's not correct. So this is actually an index outside of the table, and then you're calling this virtual function on unallocated memory on the heap that you can control. So how was this bug exploited? Well, it turns out that method table is actually variable sized, so you could get it to be the same size as a byte array, and then they corrupted the length property of the byte array so they could get read-write access to all of memory. So moving on to November and December. Something happened in December which I call the UAF-ocalypse. This was when a really, really large number of the movie clip use after freeze was fixed in Flash. There was more than 79 MCUs after free bugs fixed, and this was due to structural changes to ActionScript 2 that prevented these sorts of bugs from happening. There were also new mitigations implemented in December. There were 3 main ones. There was checksumming on the byte array class, so that previous vulnerability got read-write access to memory by corrupting a byte array class. Now this is harder to do because there's a checksum on the byte array, and if it gets corrupted, it crashes. They also implemented the isolated heap. And the isolated heap creates more heap entropy in Flash. Basically, it splits the heap into 3 portions: the data portion, the pointer portion, and the dangerous portion. And then it also splits it up by size. And what this does is it basically splits up pointers and data. And if you think about it, most exploits involve either confusing data for pointers or confusing pointers for data. So if they're on their own separate heaps, that gets a lot more difficult. And of course, this mitigation isn't perfect because a lot of objects have both data and pointers in them. But even attempting this split makes certain vulnerabilities a lot more difficult to use. And finally, some NOP slide mitigations were implemented. And this basically makes it more difficult to use the JIT to create code that you can jump into arbitrarily. And in November and December, there was a 1 day and a 0 day. To start off, there was a 1 day that turned up in the Angular exploit kit, which was interesting because it was one of the first things we saw that exploited Flash, even though it had the mitigations. And this is similar to a bug I filed in the past, and basically it's an integer overflow that leads to a heap overflow, and it is both controllable in size and controllable in the amount you overwrite. So this meant that they could use the one class that is still unchecksummed, which is bitmap data, and use that to overwrite the size and get read-write access to all of memory like it's a very large bitmap. And then there's this second vulnerability, which was an integer overflow, which led to a heap overflow in JIT. And what was especially interesting about this exploit is the SWIF actually contained two exploits. One of them was a typical vector exploit, which would have worked before August. And then there was a post-isolated heap exploit that would have worked December and forward that was so much more complex. It included such elements as long if statements nested 100 times, using both a media file and an image to fill up heap slots at different times in the exploit, triggering the bug 600 times, and then eventually they were able to correct the checksums on a byte array and then access all of memory space using that. So there's kind of two things you can learn from this. First, the mitigation didn't completely stop exploitation because this exploit turned up, but also it made it way more difficult. They had to really, really want this exploit to work to write such a complex exploit, and it was clearly very time-consuming to write as well. So moving on to 2016, nothing really exciting happened in January. There were no updates. And then 22 bugs were fixed in February. These were mostly stragglers from the big fix of the MC, use after freeze, and there were also a few fuzz bugs. And I also reported some bugs related to exception handling in Flash. And these have to do with how you design exceptions in a virtual machine. And I have my grumpy cat there, because there are two ways you can design exceptions in a virtual machine, and both designs are bad. They both have problems. One way you can design it is that, let's say you're in a native and you call into script and it throws an exception, you keep going. This is what ActionScript 2 does. And it has the benefit that you kind of always know you're in a good state because you can never unexpectedly leave the code. But the flip side of it is that developers don't always expect that that's what's going to happen. Sometimes they think if they throw an exception, execution is going to stop. So while I've never seen a vulnerability in Flash due to this problem, I have seen vulns in other VMs where people assume throwing an exception will stop things, and it doesn't, and it causes problems. The flip side is that you stop when you throw an exception, and this is what ActionScript 3 does. And this has the benefit of it being more intuitive. Even if the developer isn't expecting an exception can happen, you will still leave the code base. But the flip side is you can have dangling pointers. So there's no way, if you have a really unexpected exception, for the state of an object to get corrected. So this first vulnerability is due to the exception behavior in ActionScript 3, and it's specifically due to throwing an exception that probably should have been a fatal error, except you can catch it and use the Flash in a bad state. So this has to do both with code and with the SWIF format. And the SWIF format has an asset table that includes different assets like fonts and videos and that sort of thing. And what's especially interesting is that there's some reserved values that aren't in the SWIF. For example, there's an empty text field, and this is so that an empty text field doesn't have to get allocated every single time Flash needs to use one. But unfortunately, you can override this. So if your value in the asset table overrides a reserved value, that reserved value will just get overridden. So then you try and create a text field, and you've got your text field object, and it tries to find this empty text field asset, except it is now a font. Except this state actually gets detected. Because there's inline types for assets, it will notice, oh, this is actually a font, and we should throw an error. And it also corrects the type to be of type text field now, and this is basically just to prevent getting stuck in a loop as the player closes down. But unfortunately, because this isn't a fatal error, you can catch it. And then you can create a text field again. But now the type of this font has been corrected, so now this text asset points to something that is not a text field, it's actually a font. And then this is a type confusion vulnerability. So another exception-related bug I found is a use after free in the sound class. And this bug isn't exploitable on its own, but it was actually useful in exploiting another bug because it lets you read large portions of the heap. So you start off by creating this sound class, and then you create a byte array that has 1,000 bytes, and then you call this vulnerable function. And And what this does is it tries to take this array you provided and copy it into memory. So it does this, and then that call is fine, and then you create another byte array. And this one is only 2 bytes long. And then you call this vulnerable function again. And of course, this isn't going to work, because 2 bytes isn't even long enough to create one float. So this will throw an exception. Except before that exception gets thrown, you've freed the memory that was allocated previously to hold the PCM array. So now you've left this function, but you have this dangling pointer to memory, and then you can call the extract function and read these values out of memory. So moving on to March. March was a great time in Flash. March is my favorite time of year because there's Pwn to own. It's like Christmas, but there's Flash vulnerabilities. So there were a few new exploits found in Flash. To start, there was a big update, and a number of bugs were fixed, and one of them I exploited. And then in Pwn to own, there was a number of Flash bugs that were reported. There were 2 MCUs after freeze, real stragglers from the big fix, 1 type confusion in ActionScript 2, and 1 overflow in JPEG. And what was also interesting is there was a 0 day, which was an overflow in the bitmap class and platform-specific code. And that was kind of interesting because that was probably the first platform-specific bug I'd seen in Flash used in an exploit. So I'm hoping that's a sign that bugs are starting to get picked over enough that it's worthwhile to use platform-specific bugs where it wasn't before. So an interesting bug that I found in March as well was an exploitable bug, fuzz bug. What was kind of interesting about this one is that it was caused by a bug in a use after free check. So you know how I said they aren't making any more Flash bugs? That wasn't 100% true. There's the occasional new Flash bug, and this is one of them. In that fix of the 90 plus use after freeze, in 2 cases there was an actual bug in the use after free check that was exploitable. And it required an ASLR bypass. It's not exploitable on its own, but it did turn out to be exploitable. And the way I got around the ISO heap in this specific situation was that it turns out that the JIT allocates some objects in the data partition that have vtables. So then using that sound bug, I could read that out and use that to get the location of a vtable. So here's the bug. And I'm sure based on this POC, you can totally tell what's wrong. It's one of the shortest POCs for a bug I've seen. What's actually happening here is that when you call a method in Flash, it allocates space for the args on the stack. And in Flash, alloca it has a minimum of 8 bytes. So this will return an unallocated 8 bytes on the stack. And then it will call convert to string on this. And since you haven't actually initialized this, whatever value was on the stack before, it will call this virtual method on. And that makes this bug exploitable. So moving on to April. There were 24 bugs fixed. We started fuzzing images as soon as we saw the Pwn to own bugs that had the JPEG bug in them. Me and Mateus started fuzzing JPEGs in Flash, and we found about 5 more bugs that were similar to the Pwn to own bugs. And there were also some use after freeze reported. And there was also a 0 day in April. It was reported by Trend Micro, and it was actually in an exploit kit. And it was a type confusion bug in the file reference class. And what was kind of cool about this bug is it actually didn't work on the current mitigation set. So even though it was found in the wild, it actually didn't work on Flash at the time, although it did work on previous versions of Flash. And this was due to a mitigation, which I think was almost not even a mitigation, but happened to prevent this bug. It's 0 on free, so basically in some instances in Flash, now if you free memory, it will be zeroed. And this was because there were some use after freeze where you look at them and you're just like, how could that have ever not been noticed? Because it happened during normal use. And this was because the right thing just happened to be in memory that prevented a crash. So this point of 0 on freeze, it increases the discoverability of use after freeze a lot. It guarantees that if you have a use after free in common situations, it will crash. But what was interesting is in this situation, it actually caused this 0 day exploit to not work because they were zeroing out something that they were reading to make their exploit work. And I'm going to describe to you how this vulnerability worked. It was type confusion in AS2, and after this bug turned up, I reported a couple variants as well. So this, once again, has to do with the string conversion, the toString function. You create this object, and then you create a new text field. And so here's the script object, and it will try to initialize it. So to do this, the first thing it does is it sets the type to be of type text field, and then it tries to set the native data, but then it discovers that it needs this parameter first. So it tries to convert the parameter, except you've overridden this function, so now you call the constructor again, and you call the file reference constructor. And this is where the bug actually is. In Flash, a constructor should not, if you try to call it on something that already has the type set, it should cause an error. But in this situation, there was a vulnerability where the file reference class did not correctly do the check and did not cause an error. So this constructor would run even though there was already a type on this object. So it would set the native data to a file reference type, and then it would change the type to be a file reference even though it was already set. And then when you unwind in creating the text field, it will set the native data, overwrite it to be this new text field, and then you have a file reference that is pointing to a text field, and then this will get cast to the wrong type, and that's type confusion. So moving on to June. There were 36 bugs fixed. A lot of them were MCUs after freeze, and once again, there was kind of an echo from pwn to own. Usually when high-profile bugs get found, other people start reporting similar bugs for a while. And there was also a 0-day reported by Kaspersky, which was an out-of-bounds memory access in the open source parser. And this bug was open source. And I kind of thought it was a cool bug because, despite all the subtle and hard-to-find bugs that have been reported in Flash and found in the wild, this was actually quite a simple bug. I'd heard of bugs like this, but never actually seen one. And then this one turned up, and it's one that's in the Swift parser, so theoretically you could find it just by fuzzing Swifts, but for whatever reason this got missed by everyone and then turned up. And it's in the open source Swift parser, so you can see they're parsing this chunk, and then the bug is that they're reading this uint30 out of the Swift without checking it. So this can be way out of bounds if you want. So then you can see where this getString index is used, and you can see they're just adding it to a pointer. So obviously this can make that pointer way out of bounds, and then this turns out to be exploitable. So that's the end of the year. So some conclusions. Believe it or not, finding bugs in Flash is generally getting harder. As I said, when I started, it was 1 bug per day, and now I'm down to 1 bug per week or even less. The bugs are getting more and more picked over. As more people are using them, more people are reporting them. There's starting to be a lot more Flash research, and bugs are getting harder to find. Certain bug classes are drying up, but others are taking their place. And this kind of happened twice this year. To start off, there were the redefinition bugs, similar to the ones that were in Hacking Team, that were really popular, and then they basically all got reported, and they're much more hard to find these days. And then the same thing sort of happened with the MCUs after freeze. It got to a peak of, basically, 100 of them being fixed in 2 months, and now it's, maybe 5 or less being fixed. So that type of bug is now getting picked over. So who knows what will happen next. And Flash mitigations are definitely making it more difficult to exploit bugs, especially with low-quality bugs. We're definitely seeing fewer 0 days and especially fewer 1 days because of the Flash mitigations. And in some of the 0 days that turn up, you can tell that it was a lot more effort to exploit the bugs. So what do I think, what sort of bugs are left? Well, as I said, the movie clip used after freeze are still being used a lot, but they're getting harder to exploit, and I think as Adobe adds more mitigations, they're going to eventually have marginal utility. And as I said, the redefinition bugs are kind of gone in the future. I suspect we're probably going to see a few more fuzz bugs in media just because those have been turning up a bit lately. And there's also been a few bugs in the open source AVM. The thing about that is that the open source AVM, even though it's open source, the code is extremely complex, so there's quite a barrier to looking at it. So my suspicion is just because it's so complicated, there's still bugs in there. Also, we saw the first platform-specific bug used in a while, so it's possible that more of those will be used as bugs get picked over. And finally, everyone is talking about Flash deprecation, so maybe one day Flash will be deprecated and attackers will have to move on to something new. Personally, I think the new thing will be browsers, so that's what I'm planning on looking at next. So that's it. I want to end off by giving a big thank you to Adobe. They have been super helpful with this research, and they've obviously implemented some great mitigations this year, so thanks a lot. So that's it. I'm going to now open it up for questions.